All right, thank you for joining us today. And in this video, I have like 5 questions that we are going to go through. Let's start. So with this question, we want to calculate for C of 251 minus C of 250, which we are talking about the actual cost incurred, right? So this is very simple. All we need to do is we need to plug in 251 in this equation minus 250 in this equation. So what I'm going to do is I'm going to pick this one and solve. When I'm done, solve for this, then I'll do the subtraction. So what is C of 251? So this is going to give us 8,000 plus 200 times 251 minus 0.2, then 251 squared. So this is what I'm going to get for C of 215. Then C of 250 will be equal to 8,000 plus 200, 250 minus 0.2, 250 squared. So this is what I was doing. I was just plugging in this one by x. So now x is equal to, as I said, I think when you have a function like this, you make sure you put all of them into parentheses. So this one will be x in parentheses minus 0.2. X is also in what parentheses. So what I'm doing is I have x here, I have x here, I have x here in parentheses. So what I'm going to do is now my x here is equal to 251. So all the x is going to change it to 251. So you can see that when I'm matching this one with this one, I have 251 here, 251 here, right? 251, 251, 251, 251. So it's like it's matching with the x, right? Good. So I'm just replacing all the one in the bracket or in the parentheses with 250. The same thing for this one too. So now I need 251 minus C of 251 minus C of 250. So this is very simple to calculate. We are going to have C of this minus C of 250, which will be equal to 8,000 plus 200 and here minus 0.2251 squared minus, then I'll put it into parentheses, right? So when I do that, I'm going to have 8,000 plus 200, 250 minus 0.2250 squared in parentheses. So when I simplify, I'm going to have 8,000 plus 200 and 250 minus 0.2251 minus, so when I multiply the minus through this, everything here will change. So I'm going to have minus 8,000, then the minus time this one is going to give us minus 250, right? Then the minus here will multiply this minus here, which is going to give us plus 0.2250 squared. So we can see that this will cancel this one here, right? So if I want to group items, then I'm going to have this one to be, now I have this one with this, right? So I'm going to have 200, 251 minus 200, 250, right? So now I'm done with this and that. I can also group this and that. So I'm going to have plus, I'll write this one first before this one. So I'm going to have plus 0.2, then 250 squared minus 0.2251 squared, right? So the idea is that I'm not using calculator, so I just want to do it in a such a way that I can simplify. What you can do here is you can point this one on the calculator to get the final answer here, point this one on the calculator and get the final answer here. And then what you are going to do is you subtract this from this, and then you are going to get the same answer that I'm going to get here. So since I'm not using calculator here, now I have 200 here, 200 here, I can factor it out. So I'm going to have like 200, and when I factor it out, it will be left with 251 minus 250 plus I have this and this one too here, so I'm going to have 0.2. Then here we'll be left with 250 squared minus 251 also squared. So this is going to be 200. Then when I subtract this one, I'm going to have 1, right? So I'm going to have 1 there. Then plus 0.2. Now this one here is difference of 2 squared. So I can write this one as 250 plus 251, then 250 minus 251, right? So this is going to be 200 plus 0.2. Now when I add this, I'm going to have I think something like 501, right? Good. Then when I subtract this, I'm going to have minus 1. Nice. So that's what I'm going to have. Now what I can do is I can multiply this by that. So I'm going to have something like 200 plus. So when I multiply the negative, this one will change to what? Negative. Then 0.2 times 501 will give us 100.2. Yes, 100.2. So what you are going to get is we are going to get something like 99.8. So this is what you are going to get. So it means that let me clean up the solution. I hope you followed. So if I'm cleaning up the solution, we've gotten 99.8. So if I'm cleaning up the solution up to the top, we are going to have this one to be equal to 99.8. So that's what you are going to get at the end of the day. So it means that you can use calculator to point this one. So the results that you are going to get, then when you do, you are going to get 99.8. Now we want to find the rate of change. So the rate of change here is when we need to find c prime of x from this equation. Then when we are done, we plug in x is equal to what? 250, right? So now what is the function here? This c is it 2000? No, 8000 plus 200x minus 0.2 x squared. So let's do the differentiation. When I differentiate a constant, I'll get 0. When I differentiate x, I get 1. So 1 times 200 will be 200 minus, when I differentiate x squared, when I differentiate x squared, I'm going to have 2x, right? So now the two here will multiply the negative 0.2. So I'm going to have negative 0.4x. So that's what I'm going to get at the end of the day for the differentiation, right? Now when I'm done, I need to plug in the 250 from here. So when I plug in the 250, I'm going to have 200 minus 0.4 times 250, and I'm going to have this one to be 200 minus. So now 0.4 times 250 will be equal to 100, and this is going to give us 100, right? So that's what you are going to get. That's the results that we are going to get for the B. Now the C is asking us to, compare the results in A and B. Are they close? Should they be close? So that is a question that they are asking us. So what the conclusion that we can make here is yes, they should be close. So you can see that this is close to this, like very close. And As I was saying, I wanted to explain the when we are talking about the exact value and then the approximated value. So this right here is the exact value, right? That's the actual cost. This is the actual cost. And when you find the derivative and you plug in x, this becomes the what? The approximated value. So here what we can do is, or what we can say here is, now we can use b to approximate a. We can use b to approximate a. Why? Because this is the exact value, right? And this is the one that we are looking at the change. We are looking at finding the derivative. So we can use b to approximate what? A. So you can see that they are very close in a such a way that even if we choose that, oh, this is what is going to be the cost, we are almost there because this is approximately what? 100. So that is what we are going to get for the A. Now let's look at question 2. Now question 2 is also asking us to estimate the change in cost from producing the 101 item. Now everything here is the note, like everything here is just explaining the question here. So when asked to estimate the change or the expected change, this is where the derivative should be used, right? So here they are asking us to find the what? The estimate. We need to estimate it. So what we are going to do here is very simple. We are going to just differentiate the function as the note is talking about here. So we are just going to differentiate the function, and then if asked to find the exact change, so the exact change that we are going to find is like what we did here. This is the exact change. So we are going to have like 251 minus 250. So this one is going to be, the exact change here will be C of 101 minus C of 100. So this will be the exact change that they are talking about here. Right. So let me go through and then assist you. So now this one, since we want to estimate the change in cost, we are just going to pick the function, which is 0.0002 x to the power 3 minus 0.06 x squared plus 120 x plus 5000. Then we differentiate. So C prime of this is going to be, so now we are going to differentiate x to the power 3. When I differentiate x to the power 3 using the power rule, I'm going to have 3x squared, right? So the 3 drops down, I subtract 1. So I have something like this. Now, when I differentiate this and I'm getting this, now the 3 here should multiply the 0.002. So when I do that, I'm going to have 0.0006 x squared. So I have already multiplied the 3 by what is here. So that's what I'm going to get. Now, if I want to differentiate this one, x squared 2 is going to give us 2x because the 2 drops down, then we subtract 1. So 2 minus 1 will just be 1, which is the same as this. Then I need to use the 2 to also multiply what is here. So when I use 2 to multiply that, I'm going to have minus 0.12x. Then when I differentiate x, I get to 1. So I'm going to have plus 120. And when I differentiate the constant, I'm going to get 0. So this is what I'm going to get after the differentiation. This is what I'm going to get after the differentiation. So what I need to do is, now I need to plug in a value for x. Now the trick here is, anytime you have something like this, right? If you see this one here, when we finish the derivative, what we did, we just plugged in s is equal to 250, just straight, because here x was equal to 250 without we adding something like st or rd or nothing, right? So that is the trick. So here, since we have the st on it, it means that we need to reduce this by 1. So now our x here should be equal to 100 instead of 101. Right. Good. So with that, we can now approximate when x is equal to 100. We put them inside. Then 100 squared minus 0.12 times 100 plus 120. So this is going to give us, when I multiply this one by 100 squared is going to be like 100 squared is going to be like I think 10000. Yeah, I think yes. And then minus, when I multiply this one by this one I'm going to get 12 plus 120, and this one when I multiply I'm getting 6 minus 12 plus 120, and this should give us 114. So this is what I'm going to get. Now, if the question is asking us to find the exact change, then the exact change will be equal to C of 101 minus C of 100. Right. So this will be the exact change. And you can try it and see. When you solve this, you are going to have something like 114.0002. So you see that the exact change is this, and this is the approximated value. And you see that this is approximately the same as 114. So it means that we can use this one to approximate this. So we don't need to even look for the exact value. We can just differentiate, plug in when we lower it by just 1, and then we get it to be approximating the exact change. So that's what you need to know. That's the difference that you need to know from, like, when we are talking about the exact change, we are talking about the approximated value or the rate of change that we are talking about here. Good. Now let's look at the B. Now suppose we have 200 decks. Suppose 200 decks are being produced, and then the current cost is $28,200. What is the expected cost if an extra 10 decks are produced? So this is very simple. I will have my X, right? I'll have my X, and then I'll have my C of X. I'll have my C of X. Now, when X is like the number of decks that we produce, so when we produce 200 decks, the current cost is 28,200, right? So we can see here, when we produce 200, the cost is 28,200, right? So now when we want to do extra 10 decks, then it means that now we have like 200 plus 10. So we want to add 10 to what's here, because that is the extra decks that we want to do. So when we do extra decks, when I add it to this one, I'm going to have like 210, right? But remember, the cost for this one is 28,200, right? Plus, now what will be the cost of me producing this? So the cost of me producing this one is like, this one depends on the on the on the on the marginal cost, right? So remember, when we are talking about the C of X is equal to mx plus this, now this is the fixed cost, right? So this is a fixed cost which is here. So what we need to look for is, we need to look for now the extra cost that is going to bring. This is a fixed cost that we know, like when we produce 200, we have B, which is the fixed cost. So now here, the next thing here is mx, right? So we need to add the mx. What is x? The x here is the new quantity here. The m is the slope, right, at that particular value. So that's what we need to go and look for. So now this is going to be, if I'm writing it in terms of what we did here, then this is going to be C prime of 200 times 10. So now our x is this, and then we need to look for the gradient, which is m, at x is equal to 200 at that point. So now let's go and look for it. So now we had our C prime to be equal to this. So now we are going to plug in when C is equal to what? When x is equal to 100 into this equation right here. So let me bring this equation down here. Copy it. and let me paste it here. So now when x is 200, we have 200 to be equal to 0.0006, 200 squared minus 0.12 times 200 plus 120. So when you plug in those values, what are we going to get at the end of the day? What are we going to get? So let's do the computation and see. So this is 200. So we are going to have 0.0006 times, I think this one should be 40,000. Yes. And then this is going to give us, when I multiply this, this one should give us 24. Yes, because I have two zeros here, which will cancel. 12 times 2 will be 24 plus 120. And then this is going to give us, I think when I multiply this by this, I'm going to have, so I have 1, 2, I have 1, 2, 3, 4. So it will cancel all the 4 zeros. So it will be left with 6 times 4, which will be 24. So 24 minus 24 plus 120, and I'm going to have 120. Right. So now this right here, what is equal to this, is equal to 120, right? So it means that this is equal to 28200 plus 120 times 10, and I'm going to have 28200 plus 1200, and then when I add, I'm going to have 29400. So that's what I'm going to get at the end of the day. So this is what we are going to get at the end of the day for producing extra cost. So it means that when I want to produce extra of 10, this will be the cost. The cost will be 1200. Then I need to add it to the old cost, which will give us this. So it means that when we produce 210 dexes, we are going to have a cost of 29,400. So that will be the 2. Let's look at the 3. So now the 3, we have the average cost function where C of x is equal to this. So this is very simple. The question is asking us to find the average cost function. Now C bar is what is here. So it means that C bar of x is equal to C of x over x. But we know that C of x is equal to this. So we just do substitution, which will be 400 plus 2x all divided by x, right? And we can even go ahead and divide this. Since this is plus and divided by this can be written as 400 divided by x plus 2x divided by x. And when we simplify, we are going to have 400 divided by x plus 2. So this is what you are going to get. So this will be the average cost function. Now B, we want to look at the marginal average cost function, which is the C prime. So we just need to differentiate this function and then we are done, right? So what are we going to do? Now I'll modify the C bar function small. We had this one to be this. Now this one can be written as 400 times 1 over x plus 2, right? And this can be written as 400 x to the power minus 1 plus 2. So that when we want to differentiate, we can use the power rule to do the differentiation here. So here will be C bar prime of x to be equal to, now I need to differentiate x to the power minus 1. As I said, anytime I want to do differentiation and I see a constant multiplying the function or dividing the function, I can just bring it out. Nothing happens to it. So what I need to differentiate is I just need to differentiate this. So when I'm differentiating this will implies to -1 will drop times. Now I'll pick the x to the power minus 1, then I'll subtract 1, right? So if you saw what I did, the -1 here drops down. I maintain the equation here, but the power rule says that when I finish, I need to subtract 1. So this is going to be minus 2, right? So since I have minus, when I multiply this one by minus, I'm going to have minus 400 x to the power minus 2. And when I differentiate this constant, I'm going to get 0. So I'm not going to have anything there. So this will be the marginal average cost function. What is this? If I want to write it again, I can write this one as minus 400 divided by x squared. So that was what I'm going to get. Now the question is, what happens to the average cost function as x is approaching infinity? So now what is the average cost function? This is the average cost function. So let's write it down here. So average cost function is equal to 400 divided by x plus 2. Now, as s is approaching infinity, we are talking about limit, right? So we actually want to pick limit as s is what approaching infinity and see what is going to happen, right? So as x is approaching infinity, approaching infinity, what we are trying to do here is now we are going to replace the x by infinity plus 2, right? And now if I have this value here, like I have 400 and then divided by a big number, right? So you can think about like you having one orange and maybe a school, like one big school. Let me say UIC or any school, like they are going to share this one orange. Like just one orange that a lot of students are going to share. It means that, like everybody will get like something like 0 point something something small, so it's almost 0. So this one is going to be 0 plus 2, and this is going to give us 2, right? So that is what we are going to get from the average cost function when x is approaching what? 2. Now let's look at 4. We look at the 5, and then we are done with this. Now we assume that the revenue function has the following related to it. So we have this, that, this, and then we need to calculate for this. So now we have r of 10 to be equal to 2,550. We have r prime of 10, which is also equal to 12, and then r prime of 15, which is equal to 8. So what we need to do is we want to calculate for r of 15. So now r of 15 is approximately r of 10 plus r prime of 10, then 15 minus 10. So this is what we are going to get. So it means that this guy right here is not needed. We will need this one when the question is asking us to find for r of what? 16. So if I want to find r of 16, r of 16 will be approximately r of 15 plus r prime of 15, then 16 minus 15. Do you get it? So you see that now this will give me the r of 15. I know r prime of 15 here, and then I can also find for r of 16. Yes, so that is the idea. So now this is, what is r of 10? R of 10 is 2, 5 plus r prime, this one is 12, and then 15 minus 10 will be 5. So I'm going to have 2,550 plus 60, and this is going to be a dollars of 26.10. Yes. So this is what you are going to get for r of 15. Now let's look at the last question, and then we are done from here. The last question is this. Good. So here we have a quantity demand functions, right? And then the first question is asking us to find for the revenue function of r of x. So what is the formula for finding the revenue? So we know that revenue is equal to price times what? Quantity. But we are going to represent the quantity by x and then the price by what? P. So price times quantity. By here, price is P and then quantity is X, right? So now one thing that you need to know from here is that our revenue is in terms of what? X. So it means that we don't need P in the equation. Our revenue should be only in terms of X. So it means that we need to go and look for P and come and do substitution here. Oh, nice. Fortunate for us, we know P. P is equal to minus 0.02x plus 400, right? So since we know P here, then we can plug it in here. So we are going to have minus 0.02x plus 400 times x. And when I simplify, x will multiply this, x will multiply this. So I'm going to have minus 0.02x squared plus 400x. So that will be the revenue function. So the reason why we are calling it revenue function is that the function is in terms of x. We are not getting, a value, right? Good. But if the question is asking you to find revenue, then it means that at the end of the day, maybe they will ask you to find it at x is equal to, let's say, 2, so you get exact value, right? Now, the next question is we want to find the marginal revenue function, that is r prime of x. So since we know r of x to be equal to minus 0.02x squared plus 400x, then finding the marginal revenue function will not be difficult. We just need to just differentiate this function here. So we are going to have minus 0.02. Then when I differentiate x squared, what am I going to get? 2x plus 400. When I differentiate x, I'm going to have 1. So I'm going to have minus 0.04x plus 400. So that's what I'm going to get. Now, the next question is for us to compute r prime of 2000, right? So since we have r prime to be equal to this, then we can compute r prime of 2000. So this one will be minus 0.04 times x. So now our x is 2000, which will be 2000 here plus 400, right? So now what is minus 0.04 times 2000? I think that one should give us, I think, minus 80. Yes, because this is 1, 2, which will cancel 2 of the 0, and then 4 times 20 is 80 with a minus, then plus 400, and this is going to give us 320. So this will be the r prime. Now let's interpret your this answer here. So here what we are going to say is, you see here, anytime we are looking at the r prime of something here, remember I said in the, I think, previous question that anytime we are looking at this, and so this one was like coming from the idea of 2001s like this, right? And since we want to find the prime, we need to subtract 1 from this to get the what? The 2000, right? So the interpretation should depend on this. So what we are going to say is, we are going to say that the 2001 first item increases revenue by $1 of what? 320. So that's what you are going to get. Let me add S to this one. So that will be the interpretation, right? So anytime you look, anytime we are dealing with the marginal analysis and you see something like this, r prime to be equal to this, and you want to do the interpretation, you need to add 1 to it and then use to do the interpretation. So that's what you are going to get. Oh, that's one thing that also you need to note. Now here we have the cost here, and we want to find the profit function. So anytime they want you to find something like function, it means that your function should be in terms of like x if the function given to you is in terms of x. So now what is the formula for finding profit? So we know that profit is equal to revenue minus cost. Now what is the revenue? We had the revenue to be equal to this. This is the revenue. And then in the question we have cost. So we just need to do substitution. So revenue is equal to what is here. So minus 0.02x plus I think 400, right? 400x, this is x squared. Then minus 100x plus, is it 200,000? Yes, 200,000. So when I simplify, I'm going to have minus 0.02x squared plus 400x minus 100x minus 200,000. And then I'm going to get something like minus 0.02x squared. Then when I do the subtraction here, I'm going to have plus 300x minus 200,000. So that will be the profit, right? Now this is P. The next question is asking us to find the marginal profit. So marginal profit means that we need to take the derivative. So let's take the derivative by finding P prime of x. So the same thing as I said, if you have a constant multiplying the function, all you need to do is just maintain this function and differentiate what is here. So when I differentiate x squared, I'm going to have 2x. Then I'll multiply the 2 by the coefficient of what the x squared here, which is going to give us minus 0.04x. Then when I differentiate x, I'm going to get 1. So I'm going to get plus 300. And then when I differentiate a constant, I'm going to get what? 0. So that's what I'm going to get at the end of doing the f prime, right? That's what I'm going to get. So this will be the f prime. Sorry, that will be the p prime. Good. So let me just clean up this and move this one up there so that I can do the last question for this video. So let me move this one here. Now the question is asking us to find the maximum profit and at what level maximize profits is reached. So what we are going to do here is, now when we are talking about the maximum profit, we are looking at, if we are looking at functions like graphs, then if this is the graph function for the company, then the profit maximum will be at when we are talking about the tangent line. And remember, when you are talking about tangent line and this is f of x, then here will be f prime of x, which is at rest. So here for us to look at the profit, the maximum profit, what we need to do is we need to look for f prime of s is equal to 0. So we having this one here, we are just going to set it to 0, then we look for x. So minus, so it means that 0 will be equal to minus 0.04x plus 300. So this we are taking from here, and this is equal to 0. So we have this. And then I'll move this one to the right. So I'm having 0.04x is equal to 300. I'll divide 2 by 0.4, 0.4, and this implies that s is equal to, when I divide this, what am I even going to get? I'm going to get something like, let me check something. Am I doing the right thing? Yes, I'm doing the right thing. Yes. Okay. So when I'm doing the division here, this one is going to be like, this one is like 1, 2, 1, 2, meaning that I'll add 2 zeros to this. Then I need to divide it by 4. And then I think I need to get something like 7,500. Let me confirm if it is true. When I multiply this one by 4, 0, 0, this one will be 20. So 0, 2, 4 times 7 will be like 28 plus good. So that's right. That's right. So we are going to get the x to be this, right? So when s is equal to 7,500, that is what is going to yield the maximum profit. It means that when I plug this value here, it will be 0. It means that anything after this x, we are going to get either it's going to cost us, because anything after this x will just bring the curve down. It will decrease production. So we just need to produce up to this, and then we are done. So we want to know the level. What will be the level? So the level is now, let's plug this inside the P, and that's all. We are done. So we have gotten x to be this. So this is our x, which is the maximum profit. So we want to look at the level. So the level here will be P of 7,500, which will be equal to minus 0.027 squared plus 300,7,500 minus 200,000. Good. So that's what we need to do. And then I think when you put everything on a calculator, you should be getting something like dollars of 925,000. So you can confirm, and then you can confirm it in the comments section for us. So yeah, I think that's all of the question in this video, and then see you in the next video.